In the last lesson, we successfully ran the motors using the balancing robot board. But next, I want to show that you can use the same code to run the motors using a custom hardware. So here, let me tilt the camera again. I have the microcontroller board, and I have a different motor driver, and I'm going to run this motor using a different motor driver, and without changing anything, the code will work just fine for this motor driver as well. So in this case, what I'm using is this board. It's called X Nuclear IHM 15A1, and it has this motor driver. And as you see, it has all these connections, so without like designing PCB, you can use it directly without any problem. So right now I'm going to just quickly go through the datasheet of this motor driver, just to have general understanding how it works. So this motor driver is called STSPIN840. It's very similar to STSPIN240, but it has some differences. So first thing, as you see, it can work up to 45 volts. And also another huge difference, like substantial difference, is this parallel mode. So the rest is pretty similar. So the parallel mode, what it does is that if you set this pin, you're basically merging these motor drivers, so you can run only single DC brush motor. But what it allows us to do is to generate more current. For example, if you run two motors, it can generate up to 1.5 amps for each channel. But if you merge them, you can generate up to 3 amps. So if you set this pin, parallel pin, you just need to connect the corresponding pins of channel A and B, and you can run a single motor. But in our case, we will use the default mode, so we have separate channels in this motor driver. So in this custom circuit, what I have the motor driver, and I connected the motor to these pins of the board just to run the motors. And here I have just a power supply, so I have 12-volt power supply connected to these pins. And from the microcontroller side, what I have first, I have the ground and VDD, so ground and a 3-volt power supply coming from the microcontroller board, and also I have the reset pin and PHA and PWA signals. So if I open, so I have this pin PC9, which is I think this one, and then I have PWMA, PAA, and we have the reset pin PC8, and that's it. So we can use the same code without changing, but in a different hardware, so it will work perfectly fine. Um, and of course, I put the schematic of this of this hardware in the description. So without any problem, you can build this hardware as well. So right now I'm going to run this script again, but in this microcontroller board. So let me run the same code again. So I will restart and resume the code, and this motor should start according to our code, according to our logic. So everything is working perfectly. Another feature of this motor, of this board, is that it has these potentiometers. And what it allows us to do is that we can tune the reference voltages, so we can tune the overcurrent threshold. I'm going to set very low threshold by just rotating this potentiometer. Okay, then I would start and relaunch the code. And as you see, the motor is not rotating, even we are providing the correct PWM values, that everything is fine. Except we set so low threshold that the motor driver is not allowing the motor to run. But if we rotate the gain, so if I set higher thresholds, then restart, relaunch, so the motor is working again. So that's it for this lesson. Next, we are going to integrate a library to run the motors.